The next panel is actually a panel I wanted to host, but then I found out that Peter, well, he wanted to do it himself. So now I'm pushed from the stage and he'll come up. Please give him a big round of applause, Peter Hornik.
Hello, everybody. Hi, Celine.
I'm really excited for the next panel, which is called Quantum Computing Startups, the most disruptive deep tech discipline? Question mark? And that's what you're going to talk about, right?
Yes, absolutely. And the big question is, what do we talk about? I think everybody read about quantum computing in the past, and nobody knows what are we talking about. And hopefully, we will learn a lot about future business of quantum computing and why Lakestar invested in early 2020 in quantum computing startup Terra Quantum.
Thank you very much for hosting it, and well, enjoy yourself.
Yes. Dear Demo Day friends, welcome to our Fireside Chat in our focus area, quantum computing. Quantum computing is one of the hype topics of these days, but for very few people, it is even tangible what this technology is all about and how big this quantum leap can become with the effects on all of our daily lives in the future. We are overjoyed to welcome two extremely competent discussion partners on this topic and to shed light on this field from the investor and the startup and technology perspective. Please welcome with me on stage Julian Woköck and Markus Pflitsch. The stage is yours. A little bit more, please. One to the left, one to the right. Julian, to my right, is Senior Investment Associate at Lakestar, the renowned venture capital powerhouse founded by the European venture capital legend, Dr. Klaus Hommels. Julian focuses on investment opportunities in the DACH region. He's specifically involved in industrial automation technologies, transportation and mobility, and of course, deep technologies such as quantum computing. Lakestar was the lead investor in Terra Quantum's 15 million Series A round in 2020, and Julian is responsible for this invest. Fun fact about Julian, he's one of us. Born and raised in Essen, and now back in NRW, and hopefully we will meet him here on a regular basis in the future. Markus, to my left, is the co-founder and CEO of Terra Quantum. He's an experienced CERN physicist, senior financial executive, and of course, deep tech entrepreneur. Fun fact about Markus is he has a second life. Markus has made his career in corporate finance and investment banking before he became a founder, and from my perspective, it is extremely rare to meet someone whose expertise spans both the scientific and financial sectors. Quantum computing, let's start. For the layman, what is it and can we make sense out of it? Very, very interesting question. Markus.
Wow, you know, that's a challenge in a minute, so to say, to talk about quantum computing. Let me give it a try. You know, the basic principles of a quantum computer we know already since 100 years. It's two principles. It's called superposition and entanglement. So we have a qubit which can have any value between 0 and 1, not just 0 and 1. And then the qubits next to each other are in entanglement. And the combination of those two principles actually create an exponential speed up in compute power. And that's kind of the thrilling thing. You know, we are talking about the exponential speed up with any qubit we add, and that opens the door for tremendous applications. So in a few years, we'll be able to solve problems on a quantum computer where the best supercomputers of today would take longer than the lifetime of the universe, 15 billion years. They will do it in a fraction of a second. So it is, from my perspective, the most disruptive deep tech discipline.
It sounds a little bit frightening, to be honest. Why now? And was there kind of a technology jump?
Well, why is the technology a jump now? I mean, we do have now kind of the hardware typology which actually make it work. So we can build qubits, right? And we have various hardware typologies which are underway. I think we'll talk about it in a minute and go a little deeper, but actually Richard P. Feynman, a Nobel Prize winner in physics actually, he kicked it really off in the 80s when he said, nature is quantum, yeah? The human brain is quantum. If we want to calculate and like a human brain, we should do it on a quantum computer. And that kicked off the development, and now actually we see the fruits.
So from the 80s to today, 30 years later, it's even in the beginning. From your perspective, Julian, why now? And what has happened? And from your perspective, where do we stand now?
Yeah, very interesting one. And connecting on what Markus has said and what we heard before from Professor Mauch. So when you look at the 90s or the beginning of the 2000s, yeah, where research was still very much focused on the theoretic capabilities of quantum circuits, we have seen this exponential development of the technology where before it was just still a dream to have like an error-free or error-corrected quantum circuit. And now we're seeing first glimpses of this actually becoming reality. Yeah? And I think the most prominent examples are in 2019 by Google with the Sycamore chip, we have heard about it, and also the Chinese team of the University of Technology and Science in China with a bit different implementation, but both showing a first glimpse of there is the ability to really now show in an experiment a quantum supremacy. So even though these experiments are very much still geared to showing this goal, it shows that it is possible to achieve a speed up that is just not feasible on a classical computer. So I think that's very exciting also from an investor standpoint, where the deeper technologies now reach a certain stage where it's not fundamental research anymore, but we're moving into a commercialization, and then also in the next step to like solving real business problems. So we're coming closer to actually solving business problems out there.
If we talk about we are coming closer, does it mean, yes, there is something to do? So why is it hard to build quantum computers, and what are the underlying issues quantum computing startups have to cope with? Markus.
Well, you know, there is no physical kind of breakthrough which has to be made that a qubit and a quantum computer works, right? That's the good thing. We know how that works. It is now a scaling problem or a scaling challenge. It's an engineering challenge to build as many qubits as you can to reach a certain level of number of qubits that you can do meaningful calculations on that QPU. And there are different hardware typologies who have different challenges. I mean, the majority of the trials in the moment is based on superconducting qubits. So that means you have to cool down those qubits to a very low temperature. And that is a mechanical challenge, especially if you have many qubits kind of in parallel, right? And that generates problems that, entropy sneaks in, and a quantum computer only works if we have the wave representation, the so-called Schrödinger wave equation, which is at work. And if entropy sneaks in, so if the qubit becomes too warm, you have something which you call the collapse of the wave function, and the quantum computer is not performing anymore. So therefore, some other hardware typologies like a qubit based on photons is very interesting because they would work at room temperature, and therefore the scaling would be much, much easier, right? So that's why we call the current era the NISQ device, the NISQ era, the noisy intermediate scale quantum computing era. And that's actually why we as Terra Quantum have built a hybrid quantum computer because in the moment you can still intelligently combining classical high-performance computing and quantum computing, hybrid quantum computing, achieve better results than on classical computers and do kind of on the software side all things you can do on a future powerful quantum machine as well. That's why we built QMware, a hardware platform, where we do have 40 logical qubits. They are much more performant than those noisy qubits which need error correction. Actually, the quantum volume, it's a measure of the power of the machine. The quantum volume of QMware is superior to almost all kind of QPUs which are available right now. And that enables us actually to calculate on a quantum machine already today. So for us, quantum is now.
Okay, it sounds you choose wisely when you invested in Terra Quantum, because in the very near future, we will see new business applications. Julian, what are the interesting business applications of quantum computing?
Yeah.
What do you think?
So if we take pure quantum computing, like leaving like quantum sensing, for example, on the side, as said, all these problems that are currently intractable on the classical computing setup are very promising. And I will cluster them, for example, in three categories. Yeah? The first one being actual simulation, where, for example, simulating effects you would see in nature that are currently too complex to be represented on a classical computer, being the first. The second one actually being optimization problems. So out of a set of options, oftentimes a very large set of options, you would like to find the best solution. And the third one is actually encryption, and we can pick this up later on. I think this is a very near-term problem already, because if you look at the public-private key schemes that are used in most encryption today, these rely on the algorithms of integer factorization. Yeah? And it is theoretically proven that once you have a quantum circuit with sufficient capacity, you can efficiently solve this problem. So on this side, the quantum computers, once they have reached a certain scale, will first be able to break these encryptions, but will then also offer to generate new encryption schemes that are then secure and also quantum proof. I think the most probable also in the near term is actually optimization problems. So classical optimization problems you would see in a business. Let's say, how do I schedule my production plant? Classical routing problem, traveling salesman, all where you have a very high degree of complexity which you today iteratively solve on classical computers. I think there we will see the first applications here, and we are most excited about. Nevertheless, I think it's not the holy grail for computational problems, and Markus has picked it up already. We see the first generation being a hybrid approach, where you actually need to split up the algorithmic problem you have and decide what part of it you want to run on a classical high-performance computing platform, and which part of that is actually then the core, for example, simulation or optimization that you then run on a quantum computer. So you will have it combined, the classical computing, high-performance computing approaches and the quantum approaches.
That was an absolute broad overview. Of course, there are a lot of possibilities in the future for you. And so where does Terra Quantum play? And can you give us one understandable use case example?
Yes, sure. As I said, I mean, we really focus on kind of quantum applications for today, not for the distant futures. A lot of people say, well, is that possible already, you know, or is it just still an intellectual playground? You know, I'll show you a use case to demonstrate it is possible today. You can do very, very meaningful business applications on quantum computers already today. Terra Quantum is organized as a quantum as a service company. We deliver end-to-end solutions for corporates in 3 dimensions: quantum algorithm as a service, quantum computing as a service, and quantum safety security as a service. If we double-click on the quantum algorithm as a service, to give you a use case, we have, based on real data, analyzed something which is called collateral portfolio optimization within investment banks. Investment banks have a collateral portfolio on their balance sheet across all their client structures, exposure to a lot of asset classes like equities, government bonds, cash, and so on. That has to be optimized in terms of risk, cost, funding needs, liquidity requirements. It's a mission-critical optimization algorithm carried out on classical computers with a classical algorithm. We looked at this, developed the quantum algorithm, secured the IP, by the way, and deploy it on our QMware platform. So we deliver the full end-to-end service, and the result is that we achieve a 6 basis point improvement in relation to the portfolio size. That was a 400 billion portfolio, and that results in 120 million euro annual recurring cost saving for that bank by just moving one classical algorithm into the quantum space. And that is big bucks, right? So
absolutely, that's, let's say, shitloads of money.
Exactly. So you can really address quantum performance advantages with those machines and algos. And I'm potentially we have some time also to double click on the third column, which is cryptography, a little later, which is also very interesting because quantum cryptography, quantum safety is a big market already today.
And I've learned a new term, and you should do also QaaS. That's a new thing,
exactly.
Quantum computing as a service. And both of you mentioned data security as an important field. How will quantum computing affect this, and why data security?
I think I would give this one to Markus, who's the expert here.
I'm already in the flow, right? So yeah, quantum security. I mean, you potentially know that every classical encryption code will be hacked by a future quantum computer powerful enough. So there is the quantum threat to all classical encryption. And actually, we did some breakthrough work in analyzing classical encryption methods and showing by reversing the hash function that this will be possible. By the way, it will also be possible for all blockchain protocols. So the blockchain protocols are not quantum safe. So the whole world which deals with confidential data has to upgrade to a quantum safe standard. And that means quantum encryption. And actually, we do work in that third pillar where we deliver kind of a safety service to companies. We have delivered a protocol based on fast quantum key distribution, which actually provides this quantum security. And once you have the right quantum security and encryption, even a future quantum computer will not be able to hack and enter the system. Yeah, and why is that? I mean, we don't have the hardware yet, which is powerful enough to execute some of these kind of threats. Why? Nevertheless, I think that everybody should upgrade on a quantum secure level already today. And actually, the CTO of McAfee recently said, prepare for the quantum hack now, right? And this is because we don't know when the hardware will reach that threshold. And we should better be secure before the hardware arrives, because then it is too late. We should prepare now and not wait until the threat actually is practical and real, right? And that might be in a very short amount in time, because not every market participant in that field on a global scale, we don't have complete transparency where the hardware efforts are right now. And therefore, you have to upgrade to quantum safety today, and that's why also that is a very relevant, business-relevant market for quantum companies like us.
So it sounds, from your perspective, it's not a question, for example, in the banking area, if they want to use quantum computing, they have to and should start today.
Absolutely, and we talk, of course, a lot to CTOs of large corporates, yeah? And of course, they have a full agenda. There are a lot of issues to be dealt with, and so on. And you might then say, well, quantum is just one, but no, quantum is now. You have to act now, otherwise it's too late, especially when it comes to security. And then on the other end, also for every stakeholder, also let's say for investors, quantum is now, because there are two entry barriers into that space. The first one is scarcity of talent. There is a very, very limited amount of global quantum talent. You need kind of quantum physicists, and we have one of the largest team, hardcore quantum physicists, mathematical physicists, and you need these people, right? And this takes time until you can scale kind of those talents. Therefore, there is a rush on the market to orchestrate teams like ours. And then the second one is intellectual property. We file patents every week now because that will defend the future markets. And it's, if you come too late, it's very hard because of those two aspects to enter the quantum sector.
Julian, obviously quantum computing has tremendous business potential, but when is the right time to invest? For example, Lakestar was lead investor in early 2020 in a huge of a huge 15 million euro Series A in Terra Quantum. That was quite early, and you had no ready-to-use product. Why so early?
I think the right time to invest in quantum from an investment perspective is actually now. Yeah, so we are on the cusp of where the technologies are coming out of research into actual applications. Yeah? If you look at the corporate sector, when should the corporate sector invest? Probably now as well, but this is a bit more nuanced when it comes to you probably need to build the expertise now, and you also get in the knowledge, think about use cases, and just follow the development of ever more capable quantum computers, okay? So why did we invest in Terra Quantum in the first place? As we have heard, there is first of all a shortage of actual talent, and the question has moved from are there going to be quantum computers to when they will be there. So every big provider out there has actually published now a roadmap where the problem becomes an engineering problem versus a technical risk problem. Yes, there's still some technical risk in the different architectures, but it is a process of solving that. So we can be sure that quantum computers that are very capable will be around in the next 5 to 10 years. So how can you already as a business start engaging with this topic now? And I think here, actually Terra Quantum gives a very interesting offering right here, because the plan of Terra Quantum, Markus can go a bit deeper here, is to give businesses the opportunity today already to think through use cases, get support on the algorithm side, and then actually run these algorithms already in a simulated environment, and thereby build a sort of abstraction around or interface towards the quantum computing. And once you have established that, once the more capable chipsets, like from Google or from IBM, will become available, Terra Quantum can already be the interface here and also provide you the hybrid approach. So we think for the current market movement and technological movement we're seeing, Terra Quantum is actually in a very interesting space.
Okay, what I've learned is it was also an invest in people, of course. And so if you scale your business, do you have problems to get the right people right now to scale your business?
Well, the space is very close to academia, right? It's deep tech. So you really have to, be very close to the universities, to the excellent clusters, kind of to get the talent. We are lucky, and I think we managed to do that very good, because we also, that's also why you have to be early. We kind of build a brand. We serve already a little bit as an attractor for a kind of talent who wants to move, into the, also wants to work as an entrepreneur. Yeah, it's hard, it's a challenge. There is a talent scarcity, but so far we managed quite nicely. But that will make it really hard, for late entrants to get access to that talent. Yeah.
Okay, people, we have 1 minute left now. It's time for one last question to both of you. Well, very interesting questions. A lot of competitors all over the world. How do we make it happen that Germany hold the pace that China and the US are setting? What do you think for the next 3, 5, 10 years?
You first, Julian.
Happy to go. So I think, as we have now established, so quantum is not about if, but about when. So it's actually the time to move now, and we have seen the right initiatives also from Berlin now investing or putting out 2 billion and setting up a quantum roadmap for Germany. There are going to be capital available as well on the European level. But if you set this in comparison to what the US, what China is doing, they have also realized that quantum computing is essential to long-term competitiveness of these countries. And China today is investing 2 billion a year, and with the US Act on Innovation, with 250 billion allocated to 10 topics, where quantum computing is one of the most important. These are different scales. So to put it in a nutshell, I think the right beginnings on our side are here, and also the consortia between basic research institutes like the Fraunhofer and the private sector out there. I think the foundation is there, but now I think it comes a bit around the aggressiveness and the speed, and the relentlessness that we use to actually scale this up. And I think there we need to be a bit careful to not lose ourselves in processes and consortia and governance, but actually looking at the outcome, and really pushing the outcome.
Well, yeah, I would add that I think it's very important that you have the disruptive element of startups when you also give subsidies to support tech sovereignty and build quantum technology. We have a great research landscape in Germany, actually in Europe, but the disruption, take the automotive sector, the disruption came from a startup called Tesla, not from the incumbents. And I think the disruption in quantum computing will also be very strongly supported by startups, agile, young corporates, and therefore we have to take care that the subsidies also go into the right direction. That means we have to support a strong startup ecosystem in quantum.
So, guys, we now come to the end, and hopefully we gave you a clear answer to the question, quantum computing startups, the most disruptive deep tech discipline. My answer would be a clear yes. So, and it will be a tough race against competitors like the US and China. So let's get it on, pedal to the metal. A huge applause for Markus Pflitsch and Julian Woköck. Thank you.